Next is operations on functions. If we do addition, subtraction, multiplication, and division on real numbers, we could also do it on functions. Example, given two functions f and g in variable x, we have these operations. 1, the sum of f and g of x is just f of x plus g of x, and this is called the sum function. Also, the difference of f of g of x is just f of x minus g of x, and that is the difference function. Then f times g of x is just f of x times g of x, which is the product function. And also we have f divided by g of x is just f of x over g of x, where g of x is not equal to 0, and this is our quotient function. Note that each function is defined on the intersection of the domains of f and g, with the exception that on the quotient functions, g of x is not equal to 0. So I will write this one. So with regards to the domain of these functions, take note that each function is defined on the intersection of the domains of f and g, with the exception that the values of x where g of x equals 0 is not included from the domain of the quotient function. Okay? So basically, it says that if you want to know the domain of these functions, the sum, the difference, the product, and the quotient functions, just get the intersection of the domains of f and g, then just restrict the values of x where g of x equals 0 on the quotient function. Example, f of x is equal to x plus 1, and g of x is equal to x squared minus 1. So if we want to find the f of g of x, okay, from the formula, this is simply f of x plus g of x, and our f of x is x plus 1 plus x squared minus 1. So that is x squared plus x 1 minus 1 is 0. Also, f minus g of x is just f of x minus g of x, and f of x is x plus 1 minus our g of x is x squared minus 1. So we have x plus 1 minus x squared plus 1. So we have negative x squared plus x plus 2. Now our f times g of x is the product, which is f of x times g of x, and that is x plus 1 times x squared minus 1. So you can have the FOIL method. X times x squared, that's x cubed. Outside, x times negative 1, that's minus x. Inside, that's x squared, then minus 1. So that is x cubed plus x squared minus x minus 1. And then, for the quotient, f of g of x is f of x over g of x, which is x plus 1 over x squared minus 1. Can we simplify this one? Yes, because the denominator is difference of two squares. So that's x plus 1 over x plus 1, x minus 1. So you can cancel out. the x plus 1. So that means 1 over x minus 1. But we have a restriction that x minus 1 is not equal to 0, or x must not be equal to 1. Now, if we want to know the domain, okay, the domain of f is, obviously, it's a linear function. It's all real number. The domain of g is also all real numbers. Okay. And then, how about the domain of f plus g? The intersection of the real number and the real number is also a real number. And obviously here, whatever value of x, whatever real number you substitute to x, that function will always give a real number. Okay, so the domain is all real numbers. For the difference, again, the domain of f is r, the domain of g is r, the domain of f minus g is also all real numbers, obviously from here. Same with the product, the domain of f times g is also all real numbers. How about this one? Okay, it is said in the condition that g of x must not be equal to 0, meaning the denominator must not be equal to 0. And in that case, 1 is not part of the domain of the quotient. So we have the domain of f of g is all real numbers except 1. Or you can write this one, negative infinity to 1, union 1 to positive infinity. Let's have another example. F of x is equal to square root of 4 minus x, and g of x is equal to square root of 3 plus x. So now f plus g of x is just f of x plus g of x. So that's square root of 4 minus x plus square root of 3 plus x. So that's it. They cannot do something about it. Now for the f minus g of x is f of x minus g of x, which is square root of 4 minus x minus square root of 3 plus x. Now for the f times g of x, that's f of x times g of x, which is square root of 4 minus x times square root of 3 plus x. Here we can have 4 minus x times 3 plus x, or simply that is square root of 12 plus x minus x squared. Then the f of g of x is just f of x over g of x. So that's square root of 4 minus x over square root of 3 plus x. You can rationalize this one so that to avoid the radical sign on the denominator. So this is 4 minus x times 3 plus x, which is our product, over 3 plus x. So that is 12 plus x minus x squared over 3 plus x. Now, let's find the domain. Again, the domain is the intersection. So this 3 first. The domain of f is computed if 4 minus x is greater than or equal to 0, so that the square root of 0 or positive number is a real number, but the square root of the negative one is imaginary. So we restrict that one. So it should be 4 minus x greater than or equal to 0, or negative x is greater than or equal to negative 4, x is less than or equal to 4. Okay? So that's the domain of f. How about the domain of g? That's 3 plus x must be greater than or equal to 0. So x must be greater than or equal to negative 3. So here, this is from negative infinity to 4. And this one here is from negative 3 and 3. Negative 3 is included. Negative 3 to positive infinity. Then getting their intersection, okay, take note, if we use the real line, this is 0, this is 4, okay, it's going here, and then negative 3, it's going here. Then getting the intersection is this one. The intersection for that is from here to here, and that is the domain of f plus g, domain of f minus g, domain of f times g are the intersection of this, which is negative 3, 4, negative 3, 4, and negative 3, 4. How about the quotient? Again, the quotient is still the intersection, except that when the denominator is 0. And the denominator is 0 if x is equal to negative 3. So just do not include the negative 3. The domain of f of g is negative 3, 4. There you go. Now, aside from these 4 fundamental operations, we also have composition of functions. So given functions f and g, then the composition of f and g, which is denoted by this symbol, is called their composite and defined by the equation. Okay, do not forget this definition. The composition of f and g of x is just f of g of x. Okay, how about the domain? The domain of the composition of f and g is the set of all real numbers x in the domain of g. Okay, so meaning find first the domain of g, and then those domain is within the domain of f. Okay, the g of x is in the domain of f. So the first thing first here is find the domain of g and make sure that g of x is in the domain of f. So basically, it's just getting the intersection of their domains. Almost the same with the addition, subtraction, multiplication, and division. Example, if we have f of x is equal to x squared and g of x is equal to 2x cubed minus 1. So the composition f of g of x is f of g of x, and that is what is our g of x. That's 2x cubed minus 1, and f of 2x cubed minus 1, meaning substituting 2x cubed minus 1 on x, so that's 2x cubed minus 1 squared. Then you can simplify this one, you can expand this one. This is 4x 6 minus 2 times 2x cubed times 1 plus 1. Okay, so that's 4x to the 6 minus 4x cubed plus 1. So what is the domain of g? The domain of g is all real numbers. The domain of f is also real numbers, and g of x is in the domain of f. Okay, in this case, the domain of f of g, the domain of the composition, is also a real number. So the explanation, functions of f and g are both defined on all real numbers, meaning their domains are real numbers. Then x is any real number, then x is in the domain of g. If x is any real number, then x is in the domain of g. Okay, so it is said that both f and g are both defined on real numbers, meaning their domains are all real numbers. Now if x is any real number, then it is in the domain of g. Also, g of x is in the domain of f. Because whatever value of x, whatever real number you put on g of x, the result is real number. And therefore, it is in the domain of f, since the domain of f is all real numbers. And therefore x is in the domain of f of g. I mean f composition g. Okay, so therefore the domain of f composition g is all real number. Okay, the same applies for g composition f. Also, the domain of this is all real numbers. Let's have another example. F of x is equal to square root of 4 minus x squared, and g of x is equal to 3 minus x. So f of g of x is f of g of x. Okay, what is g of x? Again, it's square root of 3 minus x. And what is f? That's square root of 4 minus x squared. So we substitute x with the square root of 3 minus x. So that is square root of 4 minus square root of 3 minus x squared. So you can eliminate the radical sign there. That's 4 minus 3 minus x, which is square root of 4 minus 3 plus x, which is 1 plus x. So how do we define this one? How do we find the domain? The domain of g, is restriction 3 minus x must be greater than or equal to 0. Okay, and x must be greater than or equal to negative 3. X is less than or equal to 3. How about the domain of f? The domain of f, okay, it should be 4 minus x squared must be greater than or equal to 0. And from our previous lesson, this is between negative 2 than 2, or you can have negative 2 to 2. Now take note that this one here, although this one here is, let's say, 1 plus x greater than or equal to 0, x must be greater than or equal to negative 1, which is from negative 1 to positive infinity. This one here is negative infinity to 3. Okay, although it is, the result is from negative 1 to positive infinity, we shall take all the values of x in this interval that also in the domain of g, that are also in the domain of g, which is negative infinity to 3. So basically, if we take the real line, if this is 0, this is 3, that domain is, the domain of g is from here, then this result is negative 1 to positive infinity. So negative 1 to positive infinity. So here, Now it is said that find the values of real numbers in this interval that are also found in this interval. So basically, you just have to get the intersection. And their intersection is here. This is their intersection. So from here. And that intersection is from -1 to 3. Okay? So basically, the domain of f of g is just the intersection of -infinity, 3, and -1, positive infinity, which is from -1, 3. Do you follow? Okay, good. So we have practice problem. Try to solve this practice problem, and if you have answers, if you have questions, just ask during class. And its domain. If f of x is equal to square root of 9 minus x squared, and g of x is equal to square root of x minus 1.